Good afternoon, Jan.
Michael, good morning.
How do you do, sir?
Good. What about you?
Doing very well.
Welcome in winter time.
Yes. Yes, back to the regular time.
Yeah,
Well, yeah.
I thought it would be this hour, but 1 hour ago I said let's check.
Mhm.
You never know.
Yes. Time zones and
Yeah,
all the craziness that we do. But
yeah.
yeah, that's coming to an end. Oh, that's amazing.
For you, it's the last time you switch.
I believe so. Yes.
In Europe, it should have been a long time ago,
Mhm.
but they will never decide.
Mm.
Okay, I really enjoy the titles of the YouTube videos.
Yeah. Yeah. I remember when you uttered that phrase. I was like, "That's the title. I'm going to remember
uh,
that."
yeah, that one and the CRDTs with benefits.
Yep.
Well, the next title will be Spaghetti in My Head.
There we go.
No, I think I'm still gonna need 2023 to translate everything. Made a little
That's
bit
okay.
progress.
Mm-hmm.
Made a little bit progress, but nowhere where I would like to be. Um, the easy things are easy, but then I get to the structures like the composer and the build descriptor,
Mm-hmm.
and then everything turns into spaghetti. Um, First of all, one thing I think would be very useful
Mm-hmm.
because I lost quite. Wait, let me make that window smaller. Then I can share it. That virtual machine. Yeah. Um, it took me quite some time to find out how to do it. Um, so yeah, seeing Jinaga server here.
Yes. Yes, indeed.
So before, when I want to run through the code, I used the shared list application.
Mm-hmm.
Only the shared list application is so much behind now
Mm. Yeah, it is.
um, that I switched to the latest. So the client and the server have been separated. So I went to the latest one. And then I was searching and searching and searching how to debug the server. Of course, because the specification, the index.js with the specification.txt file was not working anymore. I looked into it and yeah, it can be solved, but it needs a few things from
Mm.
Jinaga and so on. So then I remembered your remark that we should be able to do it just with the post. Um, where's my, yeah, with that Postman client.
Mm-hmm.
So I said, okay, let's try it this way. Yeah, he's just running into the debugger here.
Okay.
Just go through it. I'll stop the thing. And then I tried to debug directly. I checked for a few of the tests, but that didn't help me further. Then I looked into the Docker packages, and
Mm-hmm.
finally, I just added this debug.ts file. I copied in your code from your replicator.
Mm.
That's just the code that starts the replicator. You just have to install the course package
Yeah.
to change some of the imports. But the big advantage is now you can just debug it in an easy way. So in the source map here, I added debug.ts. Then if I go to debug here, for example, here is my read in the Postgres store. I have
Mm-hmm.
a breakpoint there. So now I can just start a debug terminal. Here, node node run, no, node
Um.
slash source, yeah, /debug.ts.
Node won't be
Node
able to
dist.
run it. Node can only run JavaScript. Do you have
Yeah.
an npm
Wait.
script for it?
No, what I did was this dist.
Right. Okay, that makes sense.
Yes. Yeah. So after the debug.ts, I compiled it because I put this debug.ts in the source directory. So it is compiling to the dist folder. Here
Yes.
it is, debug.js.
And it's got the source map.
I think it should still be here. No, it's not there anymore. Here. And it uses the source maps.
Yep. Nice.
No, what's happening?
Some
Already in
of these are
use
listed.
80. Yeah. Why is 80 in use?
Do you have the?
Look, it's still the old one is running.
Yeah.
Yeah, and there it has the syntax. Okay, so I stopped the old one, run it again. Debugger attached. And okay, then we go to Postman. So now this is just make a site and ask for this. And because I already created a few blocks here, so that's in my database. So if I run this request, where's my send here? Send. So now is breaking here in the read. And so you can step through it. So if we do F10. Where is he now?
Yeah. So first it gets all the information.
He already has this.
Okay.
I pressed too many times, apparently. But so in this way, it's easy to step through. Sometimes when you press F12 to see something, he still goes to the JavaScript version. Most of the times he's using the source maps, so you don't have to use that. What was it? That link that we made before to have the to map to the source.
Yeah, I think that was necessary when we were debugging across packages. So if we had the application, and then it depended upon Janaga server or Janaga JS, then using the link, that meant that the the source code was right there in the project.
But this one is still here.
Yeah.
Depending on Janaga.
Yeah, but I don't think that we did anything that stepped into Janaga. I think we're all debugging within Janaga server.
There are a few things which are in Janaga.
Oh, okay.
But anyway, it in the
well, that's good.
model.
I never actually saw that work before. I don't think it did.
In the node models here. Yeah, but then he goes to the JS version. And you can still, because the source code is in here, in the node modules. Here, where was it? Here.
Okay.
So you can just go and look for the source code quite easily. The mapping is not 100% correct, but it works reasonably well. So
okay, well, good.
I think it would not be bad inside, so to just add this debug.ts file inside the Jinaga server and to put a small note in the README. Now, if you want, I can just make a pull request and add it to the README.
Yeah, the thing that I want to limit the number of dependencies, and that brings in cores. Well, for you to be able to hit it with Postman, you don't need cores. So yeah, you should be able to take the cores dependency and that call out, and it should still work. Yeah, we've already got the express dependency, so that's fine.
It's the only one which let's try it out. Control C. It's building without problems. Then I go to my debug here. Oh, I have my debug terminal open here. npm run build. No. In here. List debug. Yeah. And then we go here. Send it. Yeah, because he's just going from Postman directly.
Yeah.
So.
Yeah, it's only the browser that cares about that.
Yeah, I just took it over from the replicator, but in this case, it doesn't matter.
Yeah. Yeah. So then,
Right.
yeah, I think that would be pretty good.
Yeah.
Yeah, and then I can even add, or you before you submit the pull request can add a package JSON script as well. So the instructions can just be npm run debug, and then it does the things.
Just make a script here in where is it? Package JSON. Add one script here, a debug script.
Yeah, that'd be nice.
Okay, I will do that and make it a pull request.
Excellent.
Because these are small things, but it took me. For you, it's easy, but it took me quite a long time to find out what is where is the entry point of this thing.
Yeah.
How to make it work.
Yeah, and the things that that helped me a great deal were first of all, I broke the problem down into generating the SQL and then executing the SQL. That way, I could write unit tests around the SQL generation, and then integration tests around execution. So yeah, and while I was working on the SQL generation, I was actually writing SQL in in an editor and running that and saying, okay, this is the right SQL now. Copy that into the test and then make the code generate it. But then I'm not certain that it works end to end until I go all the way through the integration test. So, but yeah, my workflow, I tend to avoid debugging. So yeah, if it's the test is failing, if it's not working, then I'm going to put another assertion in the code somewhere to say, well, this is what I'm assuming is happening. Let's make that assertion, and then I leave that assertion in. It's like, okay, that's that is
another test
of the code. Yeah.
Yeah. Now I start appreciating more and more these tests, because actually all my life I've just been writing software on my own and never I never shared software with anybody. And yeah, just apart from some snippets that I hijack from the internet, usually I don't participate in another one's code. But seeing this code and then you change things and you add things, and then the question, you're so much that I'm so much concentrated on just a small portion, and is the rest still working? And these tests, they really, without understanding the whole thing, you can still be relatively sure that everything is working.
Yeah, yeah, yeah. That's
That's the big.
I think that is the key. That you you can't understand the whole thing. I don't understand the whole thing. At any given time, I understand a little bit of it, and then I allow the tests to capture that understanding, and then back away, and then oh, what? How does this thing work again?
Mm-hmm.
Okay, that's yeah, back to that.
No, I've always been used to writing the software on my own, and so even 20 years afterwards, okay, it takes time to get back into the package, but I still know, okay, it was that way, and it should be that and that, and so you can not for sure, but you can a little bit predict if I change this, what will be the consequences.
Yeah, yeah,
Um,
that
but
is a powerful thing.
okay. Then if we go to, where is my Visual Studio here, the .NET version. And let's see the code mess that is where I hardly make any progress, but okay. Let's, is this visible?
Yes, it is.
So, talking about tests. In the SQL Store tests, I added one test, which is just a copy of one of your tests. This one here. But now not the memory store, but the SQLite store.
Yeah, nice.
Yeah. So this one is not working at all for the moment. Then if we go to the SQLite store, okay, then I copy paste from your code. Started with the easy things, these two, and make them a little bit more efficient and easier. So forgot about the caching inside.
Oh, nice. Okay, yeah.
Just to
Just
make
do
it
it.
work, because I want to concentrate on this thing here.
Yeah.
So actually, this is just nothing more than just loading it from the database.
Okay. Yeah.
So
I
I
like
don't.
that approach. That's not the important
Yeah.
thing. Let's go ahead and make something
So
work, and then we can make it
I
more efficient later.
yeah I don't use a specification at all. I just put a to do here, and exactly the
Oh,
same
okay. I
for
see.
the roles.
Right.
It's 2 times the
Yeah. So
same.
it's even easier, even simpler right now. Just load them all.
Yeah, I mean,
Yeah.
and the rest we will see later. But then we get to the complicated things, where we have this result composer, where we have the builder inside the result specifications, with this result builder description, and there, yeah, I think I'm still wondering what should I do? Just translate one by one, or what is the
Yeah.
best approach here?
Um.
Because the deeper I go into it, the more classes I find,
Yeah.
and in the end you have a lot of things not implemented, and all the classes here behind. But
Right. Yeah. So already in order to get here, we've done at least two translations. So we
yeah,
started with an expression. So um,
from the specification towards um, the structure with given matches and projection.
yeah, yeah. So
Yeah,
so it yeah. So it we've already translated. And I think there was an intermediate step between there, or maybe I took that out when um, more recently. But yeah, at any point we're at this this specification structure, and we have to get to SQL. Um, Going straight from here to there turned out to be difficult when I did that in JavaScript, and so I found that there was a good intermediate step that took care of a lot of the things like allocating table aliases. Um, so this specification structure is a nested structure, but when you get to SQL, every alias, there's the aliases are not in a scope. They all have to be distinct. So going into that intermediate step allowed me to allocate those aliases. Same with the parameters. Yeah, it's all the parameters are distinct, and it's just wherever you put them inside of the structure that matters. So allocate the parameters and also store their values as you allocate them, so that then when you execute this thing, you've got the values of all the parameters. And I think that was the majority of what it did in that intermediate structure. But I think I actually did do some unit tests to go from specification to intermediate structure before doing some tests that take it all the way to SQL. And actually, I think I started those tests from the text version of the specification because that's the easiest way that I had, because I first worked on the parser. In this case, you've got Linq going to specification, so that's really where you want to start the test, like you have here.
Yeah.
But yeah, there might be an intermediate set of tests that you want to write, and then doing those one at a time, I think makes sense. So you've got a really simple specification. You write a test that that says that you can take that to an intermediate structure, where you've got two tables allocated, and then two fact tables allocated, one edge table allocated. It knows which one's the predecessor, which one's the successor, and the parameters. And so, okay, now I've got a structure that represents that. And now let me write another test that goes from Linq to SQL. And so then the code actually goes through that intermediate step, but then goes on to the SQL generator from there.
Okay. But then really try to do it step by step and not just copy paste and translate.
Right. Yeah. Yeah.
Because I think in doing copy paste and translate, I'm getting lost.
Yeah.
um,
Yeah, because there is a lot happening in there. Yeah, and I developed that algorithm step by step by making more and more complicated test paths, and I get to a point where this is pretty complicated, and now I get to the next step, the next more complicated test, and it either passes immediately or passes with a surprisingly small change, and I keep the others passing as well. So that's where I feel like, okay, I'm converging on a complete solution.
yeah, and that's where were the query tests here? So if you look into that, because here you really have
Yeah, it's
just
not showing me the shared code for some reason. Can you stop and restart the stream?
Yeah.
There we go. Yeah.
Is it better like this?
Mm-hmm.
Okay. So we are in the query tests, and there you can really see you start just for a predecessor, a successor, with small specifications, and then you build up, and the longer you go, the more complex the specifications become.
Yes.
Was that the way you developed it?
Yep. Yeah. Exactly. And in fact, I even try to commit after each one of those tests. Sometimes I'll actually commit the test and then commit the fix as two separate commits. Sometimes I'll just do it. Here's the test. Here's the fix. Commit one. So yeah, you should actually be able to see that history of how how that all came about.
Yeah, I didn't look into that history, but I will try that.
Yeah, that would
To
be.
add some sauce to the spaghetti to make it eatable. Yeah.
Nice. Yeah, I'll. In fact, we can take a look at some of the commits while we're here. So, what's the best way to do that?
I have them here. But where was it in the history that you want to look?
Yeah. Okay. Yeah, we can probably yeah, stick with toward the top there. Uh, well,
Right.
yeah. The problem I'm facing here is that I'm not seeing what what pull requests these were part of, so I can't see the full reason for it. Okay, actually, yeah, these right here probably are what we want to see.
Where was all this?
Yeah, actually, you know what? A really good way to do this would be to start from the code and then see what commit changed that code. So we can do that by doing a git blame.
I let you share
Okay.
on your side. It will be easier, I
Okay.
think.
Yeah.
You can scroll through it.
All right. Janaka.net.
Directly from the source code with git blame, search where it has been modified in.
Yes. Okay. All right. So let's start with let's start looking at the tests and
Query tests.
yeah. Yep. Yeah. Perfect. So in here, we've got the commit where we last changed this test, which actually there was only one. Or oh, okay, actually there were two. Yeah, and I thought there was a way you could just jump to the list, and get the SHA. So I see the SHA right there. So that very last one, query for successors and predecessors in memory store, that was probably a fairly simple change. But here's the oh yeah, it starts with a rename. That's gonna make it a little bit difficult. Okay, let's start with the command line, because that's there we go. Where am I? I don't think I need that, but I'll just stash it and make sure. All right. So what I want to see is where did I change this? So we are looking at query test, which is in Janaga test. So I'm going to do a git blame. then Janaga test, query test CS. And I'm looking at 21. So yeah, the last change is this one here, which if I look at, I believe it's this direction first. If you do previous to next, yeah, that's where you see it. And I'm going to furthermore do Janaga test, query test. Okay. All right, so this is the test. Yeah, this is the commit where I actually add that test. Yeah.
Yeah.
And it looks like actually, yeah, it went from null to the file. This is the commit where I created that test in the first place, or created that file in the first place. So this test has always been in this file and hasn't changed this whole time. I wonder why Visual Studio says there are two commits. So there's a neat little app that one of my friends convinced me was worthwhile. So shout out to Chris McGinnis. It's called Tower. And so if I take a look here, I've got janaga.net. Come on. There we go. So I've got the full history there. So what we can do is look for that particular commit, E28, and how long ago was that? So git log. That is from June 29. So all the way back in history. Let's see. Seems to skip. Okay. So can I? Here's an idea. Here's an idea. I'm going to check out that commit and say give it a I do this a few times tonight. Okay, so now I've got a branch called explore tests, and there we go. This has that specific set of changes. So in particular, we can see here's the creation of query test. Okay.
With that first test, yeah.
Yeah. So actually, I want a few commits in the future from this. So maybe I can find where the head ended up in here. Oh, goodness. Yeah, there should be a really easy way to just say jump to this location in the complete history so I can see what happened in the future. Okay, well, here's something else I can do. So git, I'll do LG, that's shorthand for a single line log in my scripts. So now I'm going to look at just Janaga test, query test. No, wait a minute. Oh, that's because I'm I'm on the branch that has only that one. Okay, there we go. So these are all of the commits where query test is touched in some way. So,
Yeah.
what we started with was this one way back here. Oh, it was June of the the last year. That's why it looked like it skipped. Okay, so so test for predecessors and select statements. Yeah, this might be a good one. Let's do get check out explore tests, and then get resets hard to that location. And now explore tests has a bit more history in it. So let's just take a look at this one here. Okay, so this is where I added a test that I can query for successors. Oh, okay, good. That's the second test. And then it looks like in this one, execute successor step, I actually did make it work. So in order to make it work, I first of all had to expose the role so that the store could see it. So I just turned that into a property, and then inside of the store, just if that's a successor step, then execute successor step. Well, where did execute successor step come from? Interesting. Yeah, I'm not sure.
Would it already have existed? That's bizarre.
Yeah. So, yeah, I'm not entirely sure why that would be there. So, let's see what the tests look like now. Should just have the two tests. Okay, can query multiple steps.
Still on the explore branch. Yeah.
Yeah. Okay, so that wasn't the second test that I wrote. It's the second test in the file, but apparently I wrote can query multiple steps. Oh, that's weird. I can't even see. Oh, changes in the last 12 months. Okay. That's the problem. No? Okay. Right, yeah, there we go. Okay, started the in-memory implementation, declared the in-memory store. Execute pipeline and generate. And so this is showing me the version of that file at that particular step, or at that particular commit, and it just has the one test. And then execute successor step.
Second one.
Yeah. Okay. Okay, then test for predecessors in select statement is where I added this. So yeah, I must have. Oh, okay, yeah. I chose one further into the future and then still saw something in the past. Okay, time travel is hard. I don't know how Doctor Who does it. Okay, so that means somewhere in here is where I added the execute successor step to the memory store. Let's go ahead and open the memory store. And in here, I've got execute successor step. Okay, and I can see that that was when I decided to store facts and edges in memory store, is when I added that. So I might have actually violated my own rules here and created this method before I had a test for it. So take a look at the references. I can see that here we have a reference, or we have a call to it. But if I were to go back one level, so let's reset, head to this, and don't keep the changes. Boom. Then we, I thought that I saw that it had added that call in the previous one.
Didn't you go forward instead of back?
Yeah, so that's the most recent one, and then this is all going back. So reset again. I'm not trusting my tools at this moment. I didn't see anything change here. Okay. Well, yeah. So the let me just go ahead and jump forward to. I'm going to start using switch instead of checkout. Yeah, that's a relatively new Git command, but I'm not in the habit. I need to get into the habit. Okay. Yeah, it wasn't asking to reload before. Okay, yeah, so something was wrong with the tools sensing that things needed to get updated. Okay, so yeah, the basic idea is that I would write just one test. The very first one lets me get all of the classes in place, and so I've got an idea of where I'm going when I do that very first one. So like here, I knew that I wanted to be able to do this given some starting type dot match, and so when writing this first test, that's also when I said, okay, there's going to be a public static class called given that takes a tfact, and then then I see dot match, and so I say, okay, control dot, let's generate that method, and then it generated that static declaration, although it usually doesn't have all the generics, right? And so I go through and make the generics what they need to be. It certainly doesn't know that this is an expression, so I said, nope, that should be an expression, change that. And then usually I'll just say throw not implemented exception, and then come back here and run the test, and then it should throw not implemented exception. I'll see exactly where it is, click to that line, continue from there. So yeah, first get it to compile, then get all of the not implemented exceptions out of the way, and then do just one simple thing at a time through the through that pass until I finally get down to the point. Well, actually, for this one, this syntax was already in place. It was really this this layer that I was working on. So yeah, you'll see this grow over time as we move forward. Hi, you need some shoulder time? Yeah, something that, let me switch real quick to Janaga.js because I just recently went through a similar process for Janaga.js to get this this specification language complete. So I think the last time we spoke, I had this test working where I could look for facts of type something, and then do a join, and then it would give me a specification with one unknown and a predecessor join. So yeah, since then I've completed the negative existential conditions. Yeah, so to kind of demonstrate the this process, what I can do is go back one. So let's yeah, I'm gonna just use the checkout syntax because I can't remember how to do this with switch. Yeah, there's another command now that creates branches. Anyway, yeah. So yeah, I'm gonna go back to the previous one. You know what? That one was not a terribly interesting change. Let's take a look at test negative existential conditions, parse negative existential conditions. Let's go back to this one. Okay, so now that I'm there, which is there, I want to see what did I change to get here. And it's showing it backwards, but we'll just swap red for green. So it was, yeah, let's start with this file. Copy relative path. There we go. So I added a class called Office Closed and Office Reopened so that I could parse negative existential conditions. Okay, so let's walk through that again. So we've got the company. It's got the office. I want to be able to do Office Closed. I'm going to turn on Copilot because I do remember it being just crazy good at this point. So class Office Closed. And so Copilot tells me, oh, it's not telling me. So I want office.closed as const. Come on, Copilot. All right. So this is office closed type.
Copilot should have seen all that code when you were working on the bench.
Yeah. Yeah, and I remember when I first wrote this, then I did have Copilot on, and it said, "Oh yeah, this is what you mean." So, so office closed refers to an office that we're going to close, and it also has a created at date or string because we are talking about JSON. Okay, so that's all that we need for this version of the syntax. And then come on down here, and I want to do another test. It should parse negative existential conditions. Okay. Yeah, you know what I'm going to do? I am going to reload the window because it should be saying things.
Copilot is on strike.
Okay, so now it's reinstalled. Okay, that might be it. It might be that I got signed out of GitHub. Ah. And I think I am signed in now. Okay. All right, so we start with const specification, and it should. Okay, there we go. Now it's getting things started. So, so this might be new from last time. I don't remember if we had model last time. But yeah, this is where you specify the model and you say what all the types and their predecessors are.
Yeah, we had it.
Okay.
We had it.
Yep. Okay, good. So now we're going to say facts of type office, join office to company. Well, there it's just seeing that that's what I did before. But now it's guessing at this, which is kind of cool if that were the right syntax. It's not, but that is an interesting guess to the syntax. What we want is not exists, and so yeah, we are. We can see from the type declaration we are taking a label of type office, and now we need to look for facts of type office closed and do the join office closed back to office. So figure that part out. So yeah, as long as those don't exist, then we are good, and that's the specification we're looking for. And then we expect the specification to be start with the company, do office, now join office to company. That's just as it was up above. Now it guessed not exists. Well, it's close. Bang E. Okay, so now we do U2 office.closed. Hey, I figured that out. Yeah, U2 office, join to office, and there we go. That's the specification we should expect. So in order to make things easier for myself to test, I created this expect specification method that took all of the weird stuff that I'm doing in order to make sure that I can easily read these tests, and encapsulated it down here. So now I'm doing to descriptive string 3 so that I can have this indentation there. So that way the test just reads as the intent, and none of the funny business. Okay, so if I just run just watch. Okay, so I've got a not implemented exception. Very good. And so that's the not exists. Actually, I don't remember when I added that to given TS. I expected that not to be declared there. Oh, that's right. Yeah, I was trying out how TypeScript responded to different syntax. So I was just declaring how these things should look, and then seeing if TypeScript could compile. So yeah, that's where that came from. But yeah, it doesn't exist right now. So what I want to do is produce another traversal. This is kind of my iQueryable, except it's a concrete class. And so I want this traversal to kind of augment the matches that I've already created. So it really should just take the most recent match and add a condition to it. So let's do const matches equal to. So I'm going to take this matches and going to do let's just call it match. I'm going to add something else to it. So what's that going to be? So that I want to be based on the last match. There we go. And I actually do kind of think backwards like this. It's like, this is what I want. In order to get that, I need this. In order to get that, I need this. So yeah, I've got the last match. And now I can do something with the last match. It's taking a guess, but that guess is not correct. I want the conditions. I thought it was called conditions. What is it called? Match conditions. Yeah. Okay, maybe letting it know for sure that we are talking about a match. Okay, that helped it out. So the conditions are going to be the last match conditions plus some new condition. It wants to do that inline. I'm going to stop it right there and say, well, let's define the condition right now. So, hey, that's not even imported, so let's import it. So we've got, it guessed that we have a type. We do have a type. And the type can be existential or path. So this is an existential condition. And now we've got exists, and we want that to be false. Good guess. And then matches. So somehow we want to do some child matches. And that's an object. Okay, so in order to get this existential condition, we need to take this tuple definition somehow and get some child matches from it. So this is a function that takes a proxy and then also takes our fact repository, and then so we want to run that function and then see what it ends up with. If I remember correctly, this is where I needed to keep track of the fact repository. So let me just double check. Yeah, people at work are going crazy. We just made the Dallas Morning News top 100 places to work. We are number 7 in the small business category. So,
Okay.
So yeah, people are like, "Oh, congratulations! Hey, this is awesome." So if you hear my phone buzzing, that's what's happening.
Everybody in the office is very happy now.
Yeah. All right.
Anyway, congratulations.
Yeah, thank you.
I think you are the driving force behind it, so
I will take some of the credit, yes. So yeah, in given TS, we ended up with all right. We had to do all of this for not exist. So we've got the results. Okay, that was actually much easier than I remembered. Okay, so const the result. I would just call the tuple definition with. Okay. Where did the fact repository go? Oh, that's right. I realized I don't need the fact repository because it's already in scope. So yeah, I don't. I've already got the fact repository right there, so I don't need to keep track of it there. So yeah, I changed this, and then it became really simple. Just tuple definitions from this input, and now I've got the result dot matches, I think. Oh, yeah. Yeah, the thing is that this returns U, and I don't know what U means. So, why was that not complaining here? Yeah, this... yeah, this tuple definition gives us a traversal. Oh, wait a minute. I also changed. Yeah, that's what I did. I also noticed, okay, this should give me a traversal. So I'll call that traversal of U. Yeah. And now it knows, hey, a traversal object already has matches. So dive down into that that tuple definition, figure out the matches. And at this point, when I first wrote the code, I could still remember why traversal was able to collect matches like that. Right now, that part is not in my brain. I just kind of let the tests capture that. Yeah. So, yeah, got everything there, and now that I've got the new set of matches, I should be able to return a new traversal with these matches. Still keeping the same child projections, still keeping the same input. So doing not exists doesn't change what happens on the tail. It still continues in the same direction. Okay, so here I've got just running. Hit save. It runs the test, and now I end up at a different error. So okay, this is looking good. One other thing, and so I continue in that regard. So this unknown fact type, this I think came from the fact that when I evaluated the specification in order to pull out all the fact types, I didn't yet jump into all of the conditions, and so I need to to make it go there, and then this will pass, and then it'll eventually get to a point where it's failing because the string that it produces is not this string. It doesn't know how to describe a not exists. So yeah, I'm going layer by layer in order to get this full test to work. But one last thing that I do want to call out as I'm going through this is this is one of those things that that immediately causes me to stop while I'm working on code like this. Is like, I know that this has to be the the last match. I need to take the last match and modify it. And I know, just thinking through how this works, that I can't call not exists until I have a match. However, I can't prove that just by looking at this code. And so anytime the code is making an assumption, I have to add a check.
Condition.
Yeah. Nope, just throw new error. And I'm doing not implemented all the time, so it's trained to do that for me. But you can't call not exists before calling join, because I know join is how it gets in there. So if that ever does come up, that's something that would make sense to the developer. They would know, okay, I have to have the join in there. But I know that there's no way to get here until you have a traversal, and the way that you get a traversal in the first place is that you have a model. Yeah, somewhere in there. Yeah, somewhere in here it's got a model, and that's how you get your first traversal. Select. All right, there's model. There's wait, no, it's not. It's not model that I'm looking for. It is fact repository. Fact repository of type gives you a source, and then source.join gives you your traversal. So you can't have a traversal until you've called this join. And now, as it happens, traversal itself has a join, so you can do an additional join to that traversal, but by that time you already have a match. So yeah, I can prove by looking at the rest of the code that this condition will never get hit. But I don't want to rely upon that locally, because that other code might change. But yeah, so that's the that's the process that I go through, and it's if you do get a nice tool that would let you look at one commit at a time, then that might be a good way to go through it. So if we take a look at the branch, I always forget exactly how to get there. Okay, yeah, this link right there. Yeah, so this actually, if you can find a good branch to and a good starting point to walk through, then this is a good way to go through it. Yeah.
Yeah.
Yeah. Okay, that takes you to the. Yeah. So, yeah, that's the process that I recommend. Yeah, it's not a terribly easy process to reproduce, as you can see, but when in the moment, it allows me to focus on just the one problem that is ahead of me. So yeah, even when you have existing code to look at in JavaScript and you're trying to do the same thing in .NET, then it's still a good process to use, I think.
Yeah, because I can look up in JavaScript how did you do it, and try to implement it from scratch then in .NET.
Yeah.
It will be more intelligent than just copy paste and trying to translate.
Yep.
Let's try to continue that way. Eat up the spaghetti.
Yeah.
Okay.
All right. Well,
And I
that's
will.
yeah, that's also a view of what's new in the Janaga.js yeah, specification language. It's pretty complete now. I actually went back through and looked for non-implemented exceptions, and I have just one left in there. Um, but the scenario that you would have to set up in order to hit that line of code is really complicated. So I'm wondering if I want to move on to the next step before um, coming back and fixing that. So yeah.
Might never reach that that block of code.
Mm-hmm. Yeah. Yeah. It's um, well, yeah. Actually, there is one other thing in between uh, what the code is now and reaching that block of code, and that is to support multiple givens. So actually, I think I will start developing that syntax, um, and then once I'm there, then I can set up the situation that that gets it into that state and respond accordingly.
All right. I will continue that way, and I will make that little pull request also,
Excellent.
or the debug, because that makes life easier.
Yes. Yes, indeed.
Okay, so you will have a party in the office today.
Yeah, I think so. Yeah,
Okay,
that'll be fun.
enjoy the party then, and next week Thursday.
Yes, yes. Next week Thursday, we've got Thanksgiving coming up in the States. That's still a few weeks off, um, but yeah, next week we are still here.
Okay, see you next week, Michael.
All
Thank
right.
you very much.
See you then. Yeah.
Okay, bye bye.
Bye.